Hello everyone.
Delivering Lori in 10 minutes.
Hello everyone. Very good evening. Very good evening. In fact, I can say it's good afternoon. So, um, this is Super 20 Target 2026 GATE examination. We are taking this class. So, just a moment, I think. Hello everyone. Very good evening. Very good evening. In fact, I can say it's good afternoon. So, um, this is Super just a moment. Target 2026 GATE examination. अरे भैया आवाज अंदर क्यों आ रही है? ये आवाज अंदर क्यों आ रही है? So, good afternoon, everyone. So, this is Rajat Johari, starting with the subject called RCC, and I will be solving the questions that are thought to be relevant for the GATE examination 2026. And the kind of a question that I will be solving in a class will be very helpful in order to score a good rank. Because when I say the subject RCC, RCC subject itself has a significance in a GATE examination of somewhere about 4 to 5 marks, right? So that 5 marks becomes very crucial if you are solving the problems, more and more problems, and that more problems that you are solving will create a confidence in you and bring the confidence in you, and that is where you can that is where the things can be changed, right? So, moving forward with the questions of RCC, the first question that I will be solving with you, uh, I will be giving you a time to solve that question, and after certain time I will be observing the options from you, the right options from you, and if the option is correct, definitely I will be more than happy, and if the option is incorrect, then I will be solving the same question, right? So, moving forward, what is the subject that I have told you? The subject is the subject is this is reinforced cement concrete, right? So I will be solving the questions of reinforced cement concrete, right? So this is a kind of a practice class, and where I will be solving the questions of the subject. As you can see over the screen, this is the first question, and this is a kind of a MCQ of 1 marks. This is in general been asked in a GATE examination. This kind of a question can be asked. So I will be asking you the answer, the correct answer for this question. What should be the correct answer for this question? What is the maximum uniaxial eccentricity at which factored load Pu is 640 kilonewton that can be safely applied, right? And this we are talking about the RCC column of a square size. When we are talking about the RCC column of a square size, it is 400 and 400, right? And this RCC column has a load, and that load is eccentric in nature. So therefore, there will be certain eccentricity. That is why the column is subjected to a load Pu, and the column is subjected to a moment Pu into E, right? So, based on this, you need to calculate what is that Pu value, right? What is that Pu value? Calculate. Give the answer. So I will be starting the poll, right? So I will be starting the poll in front of you. None. So poll, I'm starting with you. It is a multiple choice question. I will be giving you 45 seconds to solve this question. Now the timer has been started. Kindly give the answer of this. Kindly give the answer of this. Give the answer. Have you done this? Beta, I will ask the team to upload the notes. If you have not got the notes, definitely I will ask the team to upload the notes and you will be definitely have access of that notes, yesterday's notes, today only, right? Shali, let's see this question. This is a concrete of M20 grade, right? That is why the answer is given like this, but definitely this has to be mentioned here. So based on this grade, the solution, now see, when I talk about mu divided by FCK BD square, then the answer is 0.3, right? So what is the value of mu? This is 0.3. FCK is 20. B is 400 and 400 square. Correct? So based on this, what is the answer coming? Based on this, what is the answer coming? Anybody? Let me calculate 0.3 into 20 into 400. Yeah. So it is coming out to be 384. Mu is coming out to be 384 kilonewton meter. When we talk about this value, this PU divided by FCK into BD, this value is 0.2. Correct? So based on this, 0.3 into 20 into 400 into 400. Yeah. So it is going to be 640 kilonewton. Now you are supposed to answer the value of E. What should be the value of E? So the E value will be, mu is defined as PU into E. Correct? Mu value you know, it is 384 into 10 to the power 6, right? For this is to be Newton mm, right? What is the value of PU? This is 640 into 10 to the power 3. This is the value of E. So the E value will be E value कितनी आएगी? Let's check. 10 की power 6. ठीक है. So E आ गया आपका 0.6 meter, that is 600 mm. So what is the safe eccentricity at which the column is safe? The column is safe when the eccentricity is 600 mm. Are you getting it? Answer is C. Correct. Done. I hope this question is clear. Any doubt anybody is having? This question is from the topic called column and eccentric load. You can read this topic, and this is by LSM. So by LSM, when you're solving the question of column for the eccentric load, this is called the interaction curve. This is used, right? Moving forward, again the MCQ based question. This is of 2 marks. So tell me what is the right answer for this? Tell me what is the answer for this? So first of all, I would like to check how many people have given the right answer. So this answer was C, and 5 student answers correctly. Good. Now, what about this question? This is a question regarding to longitudinal reinforcement of the column. Tell me what is the right answer for this? Giving you a time to solve this question. And the time for this question is I can say 60 seconds you can take. 60 seconds you can take. Solve this question. Chaliye, let's see this question. So it's a 2 marks question. It is a multiple choice question. So first of all, what is the question? Which of the following statement is true regarding the longitudinal reinforcement of the column? Right? So listen carefully. The minimum number of longitudinal bars provided in a column shall be 4, and for the circular column it shall be 4 and 6 in a rectangular column. So based on this question, the first option that is given in a circular column, the recommendation says the minimum number of bars to be provided for the circular column should be 6, and for the rectangular or the square column it is minimum 4. So here in this question the option given is wrong. So therefore this one is wrong. Based on the second option, the dia of the bar used as a longitudinal reinforcement shall exceed 12 mm, shall not exceed 12 mm. So based on the recommendation, the dia of the main bar in a column should be equal to or greater than 12 mm. So this statement is again wrong. Again wrong. Now the lower and the upper limit of the cross-sectional area of the longitudinal reinforcement is 0.8% and 6% of the gross sectional area of the column. What I say is this option is certainly correct. Why? Because the minimum percentage of main reinforcement, that is longitudinal reinforcement in a column, is 0.8% of gross area, right? So this is correct. And the maximum is 6% of the gross sectional area of the column. This is also correct. Maximum percentage of main reinforcement in column is 6% when the lapping is not provided. So when the lapping is not provided in a steel reinforcement, then it is 6%. So certainly it's correct. The spacing of the longitudinal bars measured along the periphery of the column shall not exceed 300 mm. This is also correct. Right? This is also correct. So Now tell me, how many of you are agree with me the option number D is correct or wrong? The first two options are incorrect. The third option is correct. How many of you are agree that the third D option can be correct, or what you say, is it incorrect? Spacing of the longitudinal bar measured along the periphery of the column. So tell me, maximum spacing of the longitudinal reinforcement. Not along the periphery. This word is wrong. This word is wrong. So if this is a bar, so the spacing between center to center of the bar is measured, not the periphery. Right? So this is maximum. Are you getting it? Are you getting it? Center to center distance we are talking about. We're talking about center to center distance. Answer is C. How many of you have given the right answer? How many of you have given the right answer? So 8 students answer correctly. Correct. Moving forward to the next. It is a net based question, numerical ability test based question, and it is again of 2 marks. So let's have a poll for this question again. Let's have a poll for this question again. It is an integer type question. So I'm giving you a 60-second to solve this question. Giving you 60-second to solve this question. Kindly answer this. Kindly answer this. Have you solved this question? Have you solved this question? Okay. So what do you mean by the development length? Development length is defined as the minimum length of steel embedded in column or in concrete such that bond strength between steel and concrete is equal to tensile strength of steel. Correct? Is it? Is it? So when we talk about the development length, right? When we talk about the development length, what is the development length? What is the development length? Development length after derivation, it comes out to be 4 into tau BD permissible. Is it? This is the formula for the development length. Are you getting it? Clear? So, based on this formula, we need to check the dia of the bar is given as the development length in mm in compression for 20 mm dia deformed bar. Okay. So, listen. Two notes are there. You need to consider the tau BD permissible value is increased by 60% for HYSD and CTD bar. और ये किस ग्रेड में अवेलेबल हैं? This is available in these two grades, right? Second is tau BD permissible value is increased by 25% for compression steel. Clear? Clear है यहाँ तक? So, here it is defined as 415. What is the value of tau BD? This value depends upon grade of concrete. Tau BD value depends upon grade of concrete. Clear? This value depends upon grade of concrete. Now, based on the grade of concrete, it is M25 grade of concrete is used. It is 1.4. So, for M25, it is given as 1.4 Newton per mm square, right? So, based on this, if you talk about the development length, the dia of the bar used in compression is 20 mm, 0.87 Fy, Fy is 415, divided by 4 tau BD. Now, tau BD value is 1.4. As you can see, tau BD value is 1.4, correct? Now, this value has to be increased by 60% since the bar is HYSD, and since we are determining the development length for the steel in compression, so the 25% is further increased for the compression steel. So therefore, based on this results, you can calculate the development length. This is coming out to be how much? This is coming out to be how much? 644.73 mm. This kind of questions are very important. This is the answer. So यहाँ पर you can write 644.73 mm. I hope this is clear to everyone. I hope this is clear to everyone. Let me check how many people have given the right answer for this. So answer is 644.73. View results. Okay. Anyway, moving forward. This question. Now, how many of you can give the answer for this question? This is again a MCQ based 1 marks question. Take a Young's modulus of elasticity of steel given for Fe415 grade of steel. The ratio of compressive strain to tensile strain for the balanced singly reinforced section will be. So again, I am starting the poll and you are supposed to answer. It is a multiple choice question. So let me giving you a time 60 seconds in order to solve this question. Kindly solve this. Kindly solve this. Kindly solve this. Anyone? Chalo. Give the answer. Give the answer for this. Done? Okay, let me check how many of you have given the right answer. Right? So, tell me, what is the strain in steel for the balancingly reinforced rectangular section when we talk about steel and concrete both achieves its maximum strain value at the time of failure. Simultaneously. And this happens when the beam is balanced section, or I can say the limiting section. This happens in a limiting section. So, at the time of failure, the strain in steel is 0.87 Fy divided by Es. So, at the time of failure, the strain in a steel has to be greater than this. So, just before failure, the strain will be equal to this. So, this is going to be this. So, 0.87, what is the value of Fy here? It is 415. What is the value of ES here? It is 2.1 into 10 to the power 5 plus 0.002. What is the value coming out to be? Give the answer. It's 0.0037. Yeah, correct. Okay, great. What is the strain in concrete? What is the strain in concrete? The maximum strain in concrete at the time of failure is 0.0035. And in this question, they are asking the ratio of the compressive strain and the tensile strain. Obviously, this we are talking about the compressive strain because concrete strain that we are talking is a compressive strain, and the strain in steel that we are talking is the tensile strain, right? So the ratio of compressive to tensile strain, right? So ratio you can determine. So what is the ratio of strain? Strain ratio. The question is asking, that is E, and this is this. So 0.0037 divided by 0.00. What is the value? Value is how much? 0.941. Is it the answer? Answer is C. Tell me, is it clear or not? Is it clear or not? Swagatham, why you are saying it is? Okay, now correct. Yeah. Yeah. Done. Clear? This question I hope is clear to everyone. Good question. This type का question can be asked, so I will be writing it important kind of a question. Again, the last question that I have solved is also important because many times this kind of a question is asked, right? So, okay, moving forward. Now this is a question in front of you. Again, it is a MCQ question, but this time this question is of 2 marks. You are supposed to answer this question. You are supposed to answer this question. So first of all, yeah. So it is a multiple choice question. For this question, let me give you 90 seconds this time. Please solve this question. Solve this question, please. Clear? Please solve this. So beta, by mistake it is 20, it is 30, right? Okay. Typing mistake, typo error. 30. Corrected. Please give the answer for this. Please give the answer. Have you solved this question? Have you solved this question? Anyone who can answer this? Let me solve this question. So the question saying, assume modular ratio. You know what is modular ratio? This is 15. Young's modulus of elasticity ratio, right? It is given as 15, right? Now, considering the effect of creep, this modular ratio is defined as 280 divided by 3 sigma CBC, right? So, but it is not required because it is already given. That is why you don't need to have a sigma CBC value. Now, okay. If you applied any load over the column is made from two things. When you applied the load, the column is made from two things. Right? The column is made from two things. One is the steel, another is the concrete. So when we talk about the column total load, the total load is divided into a steel load and the concrete load. So some load is beared by the concrete, some load is beared by the steel. So load carried by the steel is represented as PS. Load carried by the concrete is referred as PC. Now, when we talk about the load, so when we talk about the load carried by the concrete, it is the stress, permissible stress in concrete in direct compression into area of concrete in a section. And when we talk about the force carried by the steel, so the permissible stress in steel in direct compression is referred as sigma SC into area of steel in compression. So based on this, when we talk about, right, using a longitudinal steel of 2%, as you can see, so when we talk about the total area, so the gross area, let's say it is B into D. I do not know the area what is given, but let's say the gross area is, this is a gross area of column, right? This is the gross area of the column. When we talk about the gross area of the column, out of the gross area, the area of steel is 2% of the cross-sectional area. 2% means 2, so 2% is, okay, done. So 2% of gross area, correct? So this is the area of steel. So when we talk about the area of concrete, the area of concrete is remaining area. So gross area minus 2% of the gross area is the area of steel or area of concrete. That area is 0.98 into Ag, right? So this is the gross area, right? So moving forward to this, when we talk about the sigma Cc is okay, right? So sigma Cc, done. Just a moment. Okay, done. So it is sigma Cc into Ac. AC is how much? 0.98 into gross area. And what about the sigma Sc? So when we talk about the elastic theory, based on this elastic theory we are talking about, right? This is entirely discussion based on elastic theory, right? So elastic theory is basically used in WSM method, as you know. So the stress in steel, the permissible stress in steel, the permissible stress in steel is m times of sigma Cc. It's the m times of sigma Cc. Are you getting it? It's the m times of sigma Cc. So the stress in compression steel is equal to the stress in concrete in direct compression into modular ratio, right? So based on this, I can write here m sigma Cc, and here I can write 0.02 Ag because it is 2%. So they are asking you the ratio of PS by PC, right? So when we talk about the ratio, PS divided by PC, this is m sigma Cc into 0.02 gross divided by sigma Cc 0.98. This is gross. This is cancelled. This is cancelled. Now you will be having this value. M value is 15.02 divided by 0.98. The value comes out to be how much? Let me check. 15 into 0.02 divided by 0.98. It is going to be 30. It is going to be 0.30. Yeah, it is going to be 0.3061. So in percentage, if I talk about the force carried by the steel is 0.306 of PC, right? So in terms of percentage, if I say it is 30.6% of PC, right? So answer is B. B is the right answer. B is the right answer. This is a good question. This is a good question. If there is an examination based on engineering services, this question is very important. But based on GATE examination, this can be important, but not that much. Why? Because this question is asked based on elastic theory, that is WSM. And WSM is what I can say. I cannot say they cannot ask, but the chances are less because the most of the question in a GATE examination are based on limit state method, right? So I hope this question is clear to everyone. Now, moving forward to this question, again, it is a MCQ based question. This is again of 2 marks. Now, okay, so this is being repeated. Okay, is it repeated or what? No. Just a moment. This question. Okay, 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 okay. Done, 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 done. So this is okay. By the I think there is some issue or the I think it is the same question or different question. Is it a same question or a different question? Yeah, same. Just a moment. Okay. It's the same question but wrongly typed. So skip this question. Skip it. Now coming to this question. This is a net based question again of 2 marks. So coming to this question, right? Net based question. Answer this. 2 marks question. A post tension concrete beam of rectangular section. Now first of all I will putting you the poll for this question. It is a net based question. Uh, it's an integer type question. So give the answer. Give the answer for this. A post tension concrete beam of rectangular section 200 mm wide and 350 mm deep is stressed by a parabolic cable with 10 Newton per mm square pre-stress, 0 eccentricity at the support, and 16 Newton per mm square is the pre-stress. 0 eccentricity, non-zero eccentricity. Okay, at the center of the span, the ultimate creep is this. Modulus of elasticity is this. The loss of stress due to creep in concrete is. Very good question. Good question. And I can say it is an important question also. This can be an important question. This can be an important question. Please answer this. Give the answer for this question. Give the answer. Shall I move forward? Now see, I hope you can do this question. Bolo, can you do this question? Okay, done. So what is the question saying? Let me check first. So let's say it is a post-tension beam, correct? And in this post-tension beam, the section is of 200 mm wide, right? This is, let's say, 200 mm wide. And the depth of this section, let's say, it is going to be 350 mm, correct? So right, 350 mm deep is stressed by a parabolic. Let's say this is neutral axis. This is 350 mm, right? So where the eccentricity is 0, parabolic tendon is provided. So eccentricity is 0. And when we talk about the eccentricity 0 at the ends, but there is certain eccentricity at the center, it is given to us, right? Okay. What is the question saying? The stress, the total stress is P by A, right? And just the total stress, the load is not defined, right? Let's say here it is a load, whatever the load is there. So based on this, the total stress at this point is M by Z, right? So this is the total stress at the ends. The pre-stressing moment will be 0, but here at this section that is at the center, this total stress is defined as P by A minus PE by Z plus M by Z, right? So here it is defined as this total stress value is 10 Newton per mm square, because it is talking about the MPa. MPa is Newton per mm square. And when we talk about the stress at the center, at the level of steel, is this. So at the level of steel, it's talking about now, sorry. So here it is minus, it is plus, it is minus. Okay, done. So this is given to us. And at the end, again, the total stress at the level of steel is 10 Newton per mm square. So you know how these values come, right? So based on this question, you see, let's say it is a section and we are talking about the end, right, end span. ends of span in simply supported beam. In simply supported beam, right? Now listen carefully. At the ends, the parabolic cables, the duct location is like this. So the force is applied like this, and this is eccentricity 0, right? Right. So this is eccentricity 0. Now see, the direct stress will be like this. Just a moment. Silent. Do not disturb. Okay, done. So direct stress is always P by A, right? The eccentricity is 0. So that means the P into E, the moment effect, that is P into E divided by Z, that is the bending stress due to pre-stressing moment. Here it is 0. And when we talk about the moment due to load, this is the moment due to external load, right? So this is compressive, this is tensile, this is compressive. This value is now C. At the level of steel, the stress is 0 because it is at a neutral axis, but at the bottom, the external moment stress is M by Z, right? So this is the scenario. So when we talk about the stress at this fiber, what is the stress at the top fiber? So stress at the top fiber is defined as P by A plus 0 plus M by Z. When we talk about the stress at the level of neutral axis, where the force is applied, so at the level of steel, stress at steel level, this is only P by A. This is 0. This is 0. And stress at steel level at ends is only P by A, that is given as 10 Newton per mm square. This is given. Correct? Now, when we talk about the stress diagram at the midspan, this is the neutral axis, and in a midspan, the location of duct in a post-tension beam is here, right? So therefore, the force will be applied here. So this is P, this is E. So here the stress is compressive, that is direct stress P by A, then it is the bending stress like this, correct? So this is P by Z, this is minus tensile, this is compressive plus. Then what is the stress due to external load? At top fiber it is always compressive. At the bottom fiber it is always tensile. This is M by Z, this is M by Z. Now see, what is the stress at the top fiber and the bottom fiber? Stress at top fiber is P by A, right? And this is PE by Z plus M by Z, correct? At the level of steel, let's check. At the level of steel, so at the level of steel, when we talk about the stress, the direct stress will be there, that is P by A, right? Now, here, at the level of steel, the value of Y bar is equal to E, so minus, plus. And what is the stress at the bottom? In this case, this I am talking about mid-span. What is the stress at the bottom? Listen carefully. What is the value of this M by Z at the ends? This is going to be 0. Why it is 0? At the top fiber. At the top fiber, at the ends, the stress is P by A only. Because the simple support is there. At the simple support, the moment is 0. So that is why moment is 0. So this value is entire 0. So stress at the top fiber and stress at the level of steel, both are same. Right? Now coming to here, when we talk about the stress at the bottom, this is P by A plus PE by Z minus M by Z. So steel is in just above to the bottom. So steel location is this. So when you see the steel location, so this value is PE into Y bar by I, correct? Correct? And the level of this is My bar upon I. At the level of steel, the Y bar value is always equal to E, correct? And this stress is given to us as 16 Newton per mm square. In the question, you can see 10 and 16. What does it mean? Is it clear or not? So, is it clear or not? What not possible? What is not possible, beta Swagatam? What is not possible? What is not possible? Please clear. If any doubt you are having, please clear. So at the ends, this is a load. At the ends, the moment due to this load will be zero because it's a simply supported beam. That is why this moment is zero. And when the moment is zero, this entire term is zero. So at the top fiber and at the bottom, what is the stress in this case? At the bottom, the stress is again the same. So this stress is again, this is at the end. This value is given as 10 Newton per mm square. So stress at any level, if you see, the total stress is same at the top, same at the steel level, same at the bottom. And why it is? Because the moment is zero. Moment is zero at ends. Right? But when we come to the mid span, the moment is not zero. Are you getting it or not? Is this clear or not? Beta, it's not difficult. I'm telling you, it's not difficult at all. Right? I'm just clearing the concept. What is this 16 given? What is that 10 given? Although it is not required to be solved out. I'm just telling you why, because you should know the meaning. What is the values given to, whatever the value is given to you, what is the meaning of that value? That is why I've solved in front of you this entire. What is this? This is called the analysis of a pre-stressed concrete beam. And in a pre-stressed concrete beam, when we're talking about the post-tension beam, the post-tension beam has a stress diagram: direct stress, bending stress due to P into E. This is the bending stress diagram due to external load or external movement. Right? The external load movement is zero at the ends. That is why the stress is constant throughout the depth. So the total stress diagram, when you talk about it, is only this. That is P by A is the total stress at ends. Right? At any level you can see. Correct? So is it clear or not? Is it clear or not? So moving forward, stress is given to you. Is it clear or not, beta? You just see. Is it clear? Is it clear or not, beta? You just check. Done? So, coming to the next, what is the stress at the ends, stress at the bottom, stress at the center, mid span, right? Stress at the ends. So, end 1, this is end 2, and this is mid span, that is 3, right? This is given as 10 Newton per mm square. This is 10 Newton per mm square. This is given as 16 Newton per mm square. Correct? So, when we talk about the stress diagram, it is like this. The stress at the center is 16 Newton per mm square. At the ends, it is 10 Newton per mm square. Now tell me, is it clear or not? Clear? So, what is the average stress in this case? The average stress is 10, this value. right? Plus 2 by 3, the total peak is 16 and this peak is 10. So what is the average stress? This is going to be calculation. This is going to be 6, है ना? 6 into 2 divided by 3, that is 4. So this is going to be 14, right? So this is going to be 14 Newton per mm square. So this is the average stress at the level of steel. Clear? So average stress at the level of steel, irrespective of the end span and the mid span, is this. That is 14 Newton per mm square. I hope this is clear to everyone. I hope this is clear to everyone. Tell me, clear? Now, when we talk about the question, it is given as the ultimate creep strain is this. This is the creep strain value given to you. Correct? So creep strain value is given to you. That is how much? That is how much? 40 into 10 की power 6. Okay. Clear? So 40 into 10 की power 6 is given to you. 10 की power minus 6 is given to you. Achha, okay, this is a strain. A strain has no unit. Clear? When we talk about the creep strain, and when we talk about the elastic strain, this is referred as creep coefficient. What is called? Creep coefficient. Clear? Are you getting it or not? Bolo beta. Is it clear or not? Bolo. Is it clear? Clear? So now tell me what is the ultimate creep strain. Now let me check. The ultimate creep strain is given to you. Modulus of elasticity is given to you. Bolo. Is it? The loss of stress due to creep of concrete is, so loss of creep due to concrete is, tell me, what is the loss of stress due to creep? Tell me. So, okay, done. Okay, done. So, this is solved. Okay. Stress. Okay. So, elastic. So, second is, what is stress by strain? And this I'm talking about steel, right? So, when we talk about the stress that we have calculated, that average stress is 14. 14 divided by ES is the elastic strain, right? How much it is? How much it is? Let me check. It is going to be 14 divided by 2.1 into 10 की power 6. Okay. So elastic strain value you got, right? So creep coefficient value you got. So this is going to be, okay, right. Okay. So creep strain is given to you. Okay, done. Strain value is multiplied with the strain stress value. Okay, done. Okay, yeah. So let me check what is the exactly the zero non-linear at the center of the sponge. The ultimate creep strain is this of the stress. Okay, 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 okay. This is the misconception. Okay, 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 okay. Done. You just read this entire term. The ultimate creep strain is this MPa of the stress. Okay, okay, okay. So we need to know, listen carefully, listen carefully, listen carefully. So ultimate creep strain is of average stress basically. So 10 की power 6 average stress is 14 Newton per mm square. Now it is correct. Okay. So this is going to be how much? This is going to be how much? 40 into 14. Right? 40 into 14. Okay. 40 into 14. This is 360 into 10 की power 6. This is the strain. Got it. This is the strain. Okay. So loss of stress due to creep, loss of stress due to creep is ultimate creep strain into ES. So this is ultimate creep strain into ES. ES is this. So this is going to be how much? This is going to be how much? This is going to be 560 into 2.1. Okay, yeah. It is going to be 117.6 Newton per mm square. This is the answer. This is the answer. I hope this question is clear to you. The loss of stress due to creep is 117.6. MPa means, what is the meaning of MPa? It is Newton per mm square. So this is the correct answer. You can see. I hope this question is clear to everyone. I hope this question is clear to everyone. I hope this question is clear to everyone. Clear? Done? Done, beta? Any doubt? Please ask me. Any doubt if you are having, please ask me. Earlier, what we have done, the mistake, that is in reading the question. Many times, when we read the question wrong, the solution will become wrong, right? So this is what I was considering the ultimate strain this only, but it is not this. This into stress. Stress we have calculated. Average stress is 14 Newton per mm square that we have calculated. So This is very important. This line is very important. Clear? Done. Next question is this. This is a 1 marks question, MCQ based question. Now you need to answer this. Nobody has answered this. Okay, new poll. Poll started. Give the answer of this question. Give the answer of this question. Give the answer of this question, please. What is the answer for this? Anyone? Chaliye. This is a question. A simply supported pre-stressed concrete beam is of 20-meter span that has a initial stress is 800 Newton per mm square. The slip in the jack. First of all, we need to understand it is talking about the jack, and jack is generally used in a post-tension beam. right? So in a post-tension beam, the beam is like this. This is a 20-meter span, right? The initial stress is 800 Newton per mm square. The slip is, okay, so let's say it is a steel reinforcement. This is being done with a jacking. Jack can be applied at two ends or at one end depending upon the nature. So the slippage during anchorage is delta L, this much of steel. When you have stretched the steel, this much of steel has been released accidentally while anchoring. Anchoring means just to tie up the steel reinforcement with the jack, right? So some steel has been released, some deformation has been released. So deformation released during anchorage. Anchorage means tying the steel reinforcement with jack. And this is how much? This is 2 mm, correct? So therefore, loss of strain in steel reinforcement is 2 mm divided by total length of the steel, that is 20 meter. So when you convert this m, so what is the strain? What is the strain coming out to be? The strain is coming out to be how much? Strain is, okay, this is the strain. Now therefore, when we talk about the loss of stress in steel is right. So just a moment. This is a calculation, that is 2 meter or 2 mm. Okay. Okay, done. Divided by 20. This is 0.001 0001, right, into ES. ES is how much? 2.1 into 10 to the power 5, right? So this is going to be, this is given as 2, okay? So it is 2 into 10 to the power 5, okay? So solving this 0.0001 into 2 into 10 to the power 5, this is coming out to be 20 Newton per mm square, correct? This is coming out to be 20 Newton per mm square. So the loss of stress due to anchorage slip is nearly 40 Newton per mm square. This statement is wrong. Now, second statement, let me check. The loss due to shrinkage of 28 days post-tensioning is nearly this. So first statement is wrong. If the first statement is wrong, so what does it mean? Both statements are true. This can't be correct. Only statement 1 is true. This is not correct at all. Both statements are false. We need to check this, right? Only statement 2 is true. We need to check this. So loss of stress due to shrinkage. Loss of stress due to shrinkage, right? And we are talking about the loss of stress due to shrinkage in what? Tell me. We are talking about the loss in post-tension beam. This is the value. Loss of stress due to Shrinkage in post-tension beam is defined as this. Is it or not? 0.0002, sorry, 0002 divided by log 10 t plus 2. What is t here? In this question, the t is 28 days, right? So 28 days, correct? So what is this? 0.0002 log 10 t is 28 plus 2 into what is E? ES is 2 into 10 to the power 5. So what is the value coming out to be? Now let's calculate. Let us calculate. So it is going to be log. Where is the log? Log. Okay, log 30. So this is coming out to be 27.04 Newton per mm square. Correct? So what is the answer? It is 27. Okay, nearly same. Nearly same. So I can say this statement is true. So only statement second is true. Answer is D. Answer is D. Let me check how many of you have given the right answer. How many of you have given the right answer? 0. What is this? What is this, beta? Nobody is answering right. Your, I think, pre-stress concrete portion is weak. If you people are not able to answer these questions, very simple questions, then that means your pre-stress concrete portion is weak. Follow my notes. I've shared the notes in a yesterday's class. There are slides of pre-stress concrete section, pre-stress concrete beam. There certainly you will find benefits from that notes. Please download from the app, right? So this is done. Now this is the question. A pre-tensioned concrete beam of 300 into 450 mm size has 8 wires, each of 5 mm dia, with initial pre-stress of 1000 Newton per mm square, has eccentricity of 200 mm above bottom, right? Young's modulus of elasticity steel given, Young's modulus elasticity of concrete given, the loss of stress due to elastic shortening. Okay. So, but here it is a pre-tension. The last question was of post-tension beam. This is of a pre-tension beam. So, loss of stress due to elastic shortening, they are asking you. How many of you can calculate? I'm giving you a time to solve this question. Please give me the right solution for this question. Okay, multiple choice, start. Give the answer. Give the answer. Give the answer for this. Done? Okay. So let's take this question. It is a post tension, it's a pre-tension beam. When it is a pre-tension beam, this is a beam given to you. The size of the section is also given to you, that is 350, that is 300 and 450. So this is a beam, right? This is a beam given to you. Right? Has 8 wires each of 5 mm dia. 8 wires. Okay. So what is it saying? Okay. So this is a steel reinforcement provided throughout. Now it is being asked that from the bottom it is 200 mm. So this depth of neutral axis is 225 mm, and this is, if it is 225 mm, so it is going to be 450 mm total depth. And out of 450 mm depth, from the bottom it is at 200 mm. So from the neutral axis, if I talk, what is the eccentricity? So from neutral axis point of view, the eccentricity with respect to neutral axis, it is going to be 25 mm. Correct? Correct? Okay? Right? So from bottom, above bottom, it is 200 mm. Right? So therefore the eccentricity will be not 200 mm, eccentricity of 200 mm above bottom. So whatever the eccentricity, it is with respect to steel provision above bottom, that is 200 mm. So from the bottom the steel is provided at 200 mm, therefore the eccentricity is 25. Okay. So loss of stress due to elastic shortening. So loss of stress due to elastic shortening is defined as the modular ratio into stress in concrete. And when we talk about the stress in concrete, this is the average stress in concrete. Correct? It is the average stress in concrete. When we talk about the moment is 0 here and here, and the moment is assumed 0 here. Why? Because no load is given. No external load is defined. Correct? So at a mid-span, the moment is also assumed 0. So the stress whatever the stress you are having here, there is a eccentricity, there is a eccentricity. So stress, let's check it down. Let's check it down. So this is a section. This is 300. This is 450 mm. This is 300 mm. The steel reinforcement is here, right? This is composed of 8 wires of how many dia? How much dia? Tell me. 5 mm dia. So 8 wires of 5 mm dia is provided. So what is the area of steel? Area of steel will be, okay, 0.785 into 5 into 5 into 8. This is going to be 157 mm square. Right? Are you getting it or not? Now, when we talk about the eccentricity, this is 25 mm. Correct? So, when the pre-stressing force is acting here, so there will be a direct stress like this. This is compressive, this is compressive, this is P by A. Here also it is P by A. But due to eccentricity, there will be a movement, and the movement introduced will be anti-clockwise, right? And this anti-clockwise movement will create the beam hogging. The beam will hog like this. Let's say this is a beam, right? We are talking at this location. So the moment created here is P into E and P into E here. So the beam shape will be like, right? So there will be a hogging. So there will be a tension above and compression bottom, and tension is negative, compression is positive. So here it is like this. So it is tension, it is negative, it is compression, it is positive. This is PE into Y bar. This is PE into Y bar upon I. Correct? So at the level of steel, when we talk, the Y bar again will be E. Correct? So the moment is assumed 0. So M by My bar upon I is 0. Since M is 0, no load is given in question. So therefore, the total stress at the top, at the level of steel, stress at the level of steel will be P by A, then it is plus PE into this, right? At the level of steel, this is now the stress at end, at mid span is same because the location of steel at both the location, at the ends and at the midspan, it is same. When the steel location is same at the midspan and at the ends, so the internal stresses due to pre-stressing force will be the direct stress and the bending stress. And the combination of these two stress is called the internal stress, and that internal stress is called initial pre-stress, and that is given, that can be calculated easily, right? That can be calculated easily. Now we are saying what is the value of P? Stress is given, right? So when we talk about this P, right? So this is going to be stress in steel into area of steel. Stress is 1000 given to us. Area is 157. So answer is 1.57 Newton per mm. Sorry. This is going to be, okay. This is 1000 given to you and this is 157. So this is going to be 157,000, right? So this is Newton, correct? Correct? This is the force. This is the force. Force is known to us. What is the value of P by A? This is going to be the force divided by area. What is the area of the cross section? This force is applied over the entire cross section. That is this. So this is what? Direct stress in concrete. What is this direct stress in concrete? This is going to be how much? Right? You can calculate. And more likely, what is the value of P into E divided by I? So it is 15. This E value is 25 square. What is B? I, B D cube by 12. This is the moment of inertia of a rectangular section. This is called bending stress due to pre-stressing force, eccentricity. Bending stress due to pre-stressing force, eccentricity. Correct? So this is second. So stress in concrete is defined as this. Below neutral axis, it is plus. Correct? What is sigma C? Can you calculate? What is the value of sigma C? Sigma C will be 8.44 Newton per mm square. Correct? Not 8. It is 1.20. Okay. Okay, done. So solve it. It is going to be 1.206. Right? Okay, done. So, right? Now, what is the modular loss of stress due to elastic shortening, this is going to be m into sigma c. What is the value of m? Es by EC, and sigma c is 1.206. This we have calculated. So what is this? What is this value given? It is 2.1 into 10 to the power 5. This is 3 into 10 to the power 4. So what is the value coming out to be? This value is coming out to be 8.44. Clear? This is nothing but a MPa, megapascal. So 8.44 is the right answer. I hope this question is clear to everyone. Any doubt? Any doubt? Any doubt? Okay, done. So we will be keeping the question till here. Thank you, everyone. I hope today's class is useful, and here you got the confidence, certain confidence. I'm not saying 100% confidence, but still, if you have gone through the topics, if you have practiced the questions, and if you have attempted today's class, then definitely you will be feeling certain confidence. Yes? Okay, done. Well done. So moving forward, you can join me also today at a Maha Abhyas session of RCC in the evening. This is for the English batch, right? Super 20. Again in the evening at 6:30, I will be starting the questions of RCC, correct? So there you can also attend. I will be practicing more questions with you. I will be solving more questions in front of you. You will get more confidence, right? Thank you everyone for giving us the time and listening me and watching me. Thank you. Namaskar.